Good morning, students. In previous lecture, we have discussed till Nernst equations, and now today's topic is batteries. When galvanic cells are connected in series to obtain a higher voltage, the arrangement is called battery. There are two types of batteries. One, primary batteries, and second, secondary batteries. First, primary batteries. Primary cells are those which can be used so long the active materials are present. Once they get consumed, the cell will stop functioning and cannot be reused. Example, dry cell or Lagrange cell and mercury cell. Now, first dry cell. In dry cell, in anode, zinc container is used, and at cathode, carbon or graphite rod surrounded by powdered MnO2 and carbon is used. Electrolytes are ammonium chloride and zinc chloride. Reaction at anode is zinc gives zinc ion plus electron. At cathode, reaction is MnO2 plus NH4 plus electron gives MnO and NH3. The standard potential of cell is 1.5 volt and it fails as the cell gets discharged continuously, and once used it cannot be recharged. Other topic, mercury cells. These are used in small equipments like watches and hearing aids. In this battery, zinc and Hg is used at anode and paste of HgO and carbon is used at cathode, and paste of KOH and zinc oxide means ZnO are electrolytes. At anode, reaction is Zn plus 2OH plus ZnO, and at cathode, reaction is HgO plus H2O plus electron gives Hg plus 2OH minus. Overall reaction of battery is zinc plus HgO gives ZnO plus Hg. The cell potential is approximately 1.3 volt and remain constant during its life. Now, second types of batteries, secondary batteries. Secondary cells are those which can be recharged again and again for multiple uses. As for example, lead storage and nickel cadmium battery. Now first, lead storage battery. In this battery, lead is at anode and grid of lead packed with lead paste is used as cathode, and 38% solution of H2SO4 is used as electrolyte. Reactions at anode and cathodes are: at anode, reaction is Pb plus SO4 minus 2 ion gives PbSO4 plus 2 electron. And at cathode, PbO2 plus 4Hd plus SO4 gives PbSO4 plus H2O and aqueous H2SO4. To discharge or to recharge the cell, it is connected with a cell of higher potential, and this cell behaves as an electrolytic cell, and the reactions are reversed. Pb and PbO2 are regenerated at the respective electrodes. Now, other topic is fuel cells. A fuel cell differs from ordinary battery in the sense that the reactants are not contained inside the cell but are externally supplied from an external reservoir. Fuel cell is used in space vehicles, and in this cell the two gases are supplied from external storages. In this cell, carbon rods are used as electrodes with KOH as the electrolyte. At cathode, reaction is O2 plus 2H2O plus 4 electron gives 4 OH minus, and at anode, reaction is 2H2 plus 4 OH minus gives 4 H2O and 4 electron. Overall reaction is 2 H2 gas plus O2 gas gives 2 H2O. Now, other topic is corrosion. Corrosion involves a redox reaction and formation of an electrochemical cell on the surface of iron or any other metal. At one location, oxidation of iron takes place at anode, and at another location, reduction of oxygen to form water takes place as cathode. First, we get oxidized to Fe plus 2, and then in the presence of oxygen, it forms Fe plus 3. And then in the presence of oxygen, it forms Fe plus 3, which then reacts with water to form rust, which is represented by Fe2O3 XH2O. And at anode, reaction is 2Fe gives 2Fe plus 2 ion plus 4 electron. And at cathode, reaction is O2 gas plus 4H plus 4 electron gives 2H2O. Overall reaction 2Fe plus O2 plus 4H plus gives 2Fe plus 2 plus 2H2O. Rusting of iron can be avoided by painting or by coating it with some other metals like zinc. The latter process is known as galvanization, as the tendency of zinc to get oxidized is more than iron. It gets oxidized in preference and iron is protected. This method of protecting one metal by the other is also called cathodic reprotection.